everyone. Today we are going to see about the ideal op-amp characteristics. So why it is called operational amplifier? So because the operational amplifier amplifies the input signals as well as it performs the mathematical operations like adder, subtractor, differentiator, integrator, etc. So that's why it is termed as operational amplifier. In short, it is termed as op-amp. So today we are going to see about the ideal op-amp characteristics. So in the op-amp, we have two inputs, that is the non-inverting terminal and the inverting terminal. And we have one output V0 at the sixth pin. And we have two power supplies plus VCC and minus VCC. Here, the voltage at the non-inverting terminal is termed as V1 and the voltage at the inverting terminal is termed as V2. So here we have the following op-amp characteristics. The first one is the infinite voltage gain. As we know that gain is defined as the output by input. Here the output is V0 and the input is Vd. That is the differential voltage which is V1 minus V2. That is the voltage at the non-inverting terminal minus the voltage at the inverting terminal. Here the voltage gain is infinite, meaning that the denominator, that is V1 minus V2 or Vd is equal to 0. So here for infinite voltage gain, we have concluded that the Vd is equal to 0 or V1 minus V2 is equal to 0 or the voltage at the non-inverting terminal and the voltage at the inverting terminal are equal in case of infinite voltage gain. The next one is infinite input impedance. So the input impedance is denoted by Rin, and this ensures that here the input impedance for the ideal op-amp is infinite. That is Rin is infinite means the current is 0. So for the infinite input impedance, the current entering the op-amp is 0. That is I1 is the current entering the non-inverting terminal and I2 is the current entering the inverting terminal. So for the ideal op-amp, the current entering the op-amp is 0. The next is the zero output impedance. The output impedance is denoted by R0. Okay, so since the output impedance is 0, which ensures that any number of other loads can be driven by the op-amp. The next is the offset voltage. So what do you mean by an offset voltage? So when the inputs V1 and V2 are 0, the output should be 0. Supposing if there is any voltage at the output, then it is referred to as output offset voltage. Okay, so in the ideal op-amp, the offset voltage is 0, meaning that for input 0 input voltage, the output is 0. So that is the meaning for the 0 offset voltage. The next is infinite bandwidth. So here, what do you mean by bandwidth? So bandwidth is the range of frequencies for which the amplifier's performance is constant is called the bandwidth. So in the ideal op-amp, the bandwidth is infinite. So meaning that the gain of the op-amp is constant for all the frequencies, that is from 0 frequency till infinite frequency, that is for DC as well as AC. So we have concluded that since the op-amp, ideal op-amp has infinite bandwidth, this op-amp amplifies the DC signals as well as the AC signals. So the next one is the infinite slew rate. So slew rate is mentioned as the maximum rate of change of output with respect to time, that is dV0 by dt. So that is when the input voltage is changing, then the output should also be immediately changed. Okay, for example, if we are giving a step input as the input voltage, the output should also immediately change. Okay, so that is called as slew rate. So infinite slew rate indicates that the output changes instantly or immediately as the input voltage changes. Thank you so much for watching my video. Thank you.